Now let me take a reaction. A is converted into product. Um, I'm just going to start this reaction. I'll say I started that the reaction has not started. The time is 0. Time is 0. At the time 0, the concentration is A. This is my initial concentration. When the reaction starts, let me say at time say T1, the concentration will decrease. The reactant concentration will decrease as the reaction starts. As the reaction proceeds, the reactant concentration decreases with time. So the time actually increases. Maybe let me say some 2 minutes or 3 minutes. At time T1, the concentration is, let me say, A1, and at time T2, let me say concentration A2, and etc. So at various time interval, I am measuring the concentration of reactant, or you can also measure the concentration of product, whichever is. Let me say here the time in the x-axis and the concentration in the y-axis is plotted. Concentration in the y-axis is plotted. If you plot, then you will have a curve. I have taken a reaction. I am carrying out this reaction. I have just measured the concentration of reactant at various time interval. At the beginning, the initial concentration is A, and then at various time, the concentration is measured by any one method, maybe volumetric, or maybe you can use spectroscopic, UV spectroscopy you can measure, you can use. So at various time, the concentration of the reactant is measured, and then it is plotted, and you will have a curve of this kind. What I'm going to do here is, I said average rate, and instantaneous rate. Instantaneous rate. Instantaneous rate is more significant than average rate. What do you mean by average rate? Average rate is, see, at this time the concentration is this, and at this time the concentration is, say, this is A1, this is A2, this is, say, for example, T2 and the T3. At time T2 the concentration is A2, at time T3 the concentration is A1. So the concentration is decreasing when the time goes from T2 to T3. I know rate is defined as change in concentration. The change is actually A2 minus A1. The change in concentration with the time interval T3 minus T2. Right. T3 minus T2. So this time interval is matters. If the time interval is large, then the rate is said to be average rate. Why? Because at every second passes, the reaction rate is actually changes. For every second the reaction rate is decreasing, the reaction rate changes. Every fraction of time the concentration changes, and accordingly the reaction rate also changes. So at every second, at every time here, at every time, since the reaction rate changes, so I have taken a large time interval, so the rate will not be so accurate. It gives me the average rate. This is called a average rate. And instantaneous rate is actually the rate at particular time. Then you are going to decrease this time interval. Say the same concentration is versus time is plotted, and you will get the same curve, but the time interval must be very small. That is, infinitesimally small time interval should be taken, or you can say that at this particular point of time you will have to find out the rate. At this particular point of time, you will have to find out the rate. This is done by just uh, just a tangent is drawn. A tangent is drawn at this time, and now you take a slope. It's slope for this straight line. So at this point of time t, you are just drawing a tangent, and you take a slope for this straight line. That will give you instantaneous rate. Instantaneous rate will be given, or simply I can write the change in concentration dy with the time change in dt. This is called instantaneous rate. This is called average rate. Here you'll say change in, say, concentration with the change in time. So here the time interval will be large, accordingly the concentration difference also will be large. Here the time interval is very small as possible, and also dy is also will be very small. So at every point you are measuring the concentration. So that is the meaning of instantaneous rate at the average rate. Then I'll explain. Okay, then I'll move to a problem, as another problem, a second problem. This is a second problem. Here, look at the problem. A rate of homogeneous reaction. A rate of homogeneous reaction. This is homogeneous reaction. The rate of this reaction is doubled when the chlorine concentration is doubled. See why I have explained the rate. We have to measure the rate of this reaction. How will you measure? Of course, you'll have to concentration. You have to measure the concentration with the time. So that is why I explained rate, average rate, and instantaneous rate. Here, look at this problem. You are measuring the rate of this reaction. Okay, the problem is when the rate of the reaction actually is doubled when the chlorine concentration is doubled, but increases by a factor of 8. Increases by a factor of 8 when the concentration of both the reactants are doubled. Okay, then if I double the concentration of chlorine, reaction rate is doubled. When I increase the concentration of chlorine, double the concentration of chlorine, and if I double the concentration of NO, then the rate becomes 8 times increases. The rate 8 times increases. Okay, this is the experimental data. When I explained the rate equation and the order of chemical reactions, I said you'll have to do an experiment to find out the order and to construct a rate equation. So look at this problem. You're supposed to do an experiment. You have to find out their concentrations, their amount. You have to calculate. You have to find out, and you have to find out the rate. Okay, then what is the question? Question is determine the overall reaction order and the order with respect to NO and Cl2. So they are asking you to find out overall reaction order and order with respect to NO and Cl2. How will you solve this problem? Very simple. I just write a general rate equation. See, rate equal to K. NO is involving. NO is a reactant, and the chlorine molecule is also reactant. What I don't know is the order with respect to NO and the order with respect to chlorine. I don't know. What is the given data? When the chlorine concentration is doubled, that is, I'll write the equation. When chlorine concentration is doubled, 2 times of chlorine, I don't know this N. I have to find out the value of M and N. When the concentration is doubled, I have to have the rate will be 2 times. The rate will increase 2 times, double. Okay, then I don't know the N. Okay, if I substitute, if I give value 1 for this N, I'll write 2 power Cl2 power 1 equal to 2 times of rate. Right now, this side 2 power 1 is 2 into K NO power M and the chlorine concentration power 1. This is 2 times of rate. So this is 2 into this is the rate. So I get it is equal to 2 times of rate. So from here I found the value N equal to 1. Right? So very simple. When I double the concentration, the rate is actually doubled. When you give N equal to 1, you'll have to give n the value of N equal to 1 to get 2 times of rate. If you give n equal to 2, what will happen? 2 power 2 becomes 4. The rate becomes 4 times. When you give n equal to 0, then rate does not depends on chlorine. When n equal to 3, it becomes 8 times because 2 power 3. So when n equal to 1, when you double the concentration, the rate will be doubled. So with respect to chlorine, the order is 1. With respect to chlorine, order is 1. Then what is that? So you are doubling the concentration of chlorine and doubling the concentration of nitric oxide. The rate increases 8 times. So now I use the same rate law. The rate now becomes 8 times of rate. Now I am doubling the concentration of NO power M, and also I have doubled the concentration of chlorine N. If I give M equal to 1 and N equal to 1, if I give M equal to 2 and N equal to 1, then see 2 into NO power 2, 2 into Cl2 power 1. This is K times 2 square 4 concentration of N power 2, and this is 2 power 1 2. This is chlorine power 1. This is 4 into 2 8 K NO power 2 and Cl2 power 1. This is 8 times of rate. This is 8. This is rate. This is equal to rate. 8 times of rate. So therefore, when you double the concentration of NO, when you double the concentration of chlorine, the rate becomes 8 times. 8 times the rate actually increases. This is possible only when M equal to 2 and N equal to 1. Therefore, I can write this general rate equation as rate equal to K times NO power 2 and Cl2 power 1. This is the rate equation. This is rate equation. And the order, overall, what is order? It is a sum of concentration power in the rate law. So therefore, overall order of the reaction equal to 2 plus 1 equal to 3, and this is third order reaction. So this reaction is third order reaction. This reaction is third order reaction. And with respect to NO, the order is 2, and with respect to chlorine, the order is 1. So here we have a very simple problem, right? If you just think of this problem, that you are doing an experiment, that you are carrying out this reaction and you are measuring the concentration of either chlorine or NO by some method, and this is your observation, that is, when you double the concentration of chlorine, the reaction rate is doubled, and also you are doubling the concentration of both the reactant, and then the rate is increased by 8 times. This is the experimental observation, and from this experimental observation you can find out the order of this particular reaction. A simple problem. Okay.